Hello there and welcome again. My name is Michael Fudge and this is another episode of Learning to Program in Java. We're up to Lesson 6. Lesson 6 is the culmination of all the lessons we've learned so far. Now we're going to get down to business and learn to create our own classes and then build objects from those classes. So on the agenda today, we'll talk about some conventions that we use when designing our own classes, specifically how we create constructors, the difference between public and private members, and when is it appropriate to use a public member and when is it appropriate to use a private member. And along the way, we'll introduce some object-oriented concepts like encapsulation and how it applies to data or the state of your class. And then we'll get into some Java stuff like what is this? Now, the best way to learn how to build classes is to use a real-world example. So what better example to use than a fun example, one where we build a dice roller. As you can see in my picture, I've got all sorts of crazy shaped dice, and if you've ever played a role-playing game, you'll know that you need all these different types of dice. 12-sided dice, 10-sided dice, 4-sided dice, 6, 20-sided, 30-sided. So what we'll do is we will build a class that allows us to create a die, which is the singular version of dice, of any side that we want. So we can create a 9-sided dice or a 4-sided dice. That will be the state of the class. It will have a number of sides, and then it will also be able to tell us what the current value of the die is. Does it say 7 or 10 or 3? And then this dice roller will have one behavior, roll. When we call the roll method, it will roll the die and return its current value. All right, let's get started. The first thing I'm going to do is create a new project to hold my class and then my sample program that will run the objects I create with my class. So I'm going to press Control-Shift-N. I'm going to pick Java Application. The name of my application is going to be called N-Sided Dice. And when I do this, it will make a Java program called N-Sided Dice Java. I'm going to just rename this to N-Sided Dice Run. So I'm going to right-click, refactor, rename, and I'm just going to call this N-Sided Dice Run. Okay, let me clean up the code a bit. The class that you see before you is the class that contains the main method, and this is the method that is going to use my die class. I have not created the die class yet. The convention in Java is that every class that you create goes into its own .java file. I can place those .java file in different packages if I want. What I'm going to do is I'm going to make another Java class inside this N-Sided Dice package that I already have right here. So to do that, I'm just going to click here and do New Class, and I'm going to call this Die, because the singular of dice is die. I'm going to clean it up. And you see, I just have this really boring file here called die Java, and it just says public class die. And then in this other tab, I still have the other class. And this is the main class that runs and does stuff. This is just my class to implement what it means to be a dice. If you remember back to the slide I showed you before I jumped into code, to be a die, you have certain states and behaviors. For example, I might want to be able to roll my die, or get the value on the face of the die. I also need to be able to configure the number of sides, so I might have to get sides, which will return the number of sides on the die. Is it a 6-sided die or a 12-sided die? And then I need to be able to set sides, which will configure, given a parameter of sides, it will reconfigure the die to be a certain number of sides. So I can take a die, create it, make it a 6-sided die, and then use set size to change that die to a 12-sided die if I want. These are my states and behaviors for my class. As you can see, I haven't written any code yet. I'm just kind of brainstorming this. But one important thing that every class should have is called a constructor, and it's a special method, public die. So the name of the method matches the name of the class. That's what makes it a constructor. The method that is called when you new up an object of the class, that is when you say die d equals new die, right? When you say that, when you say this when you're using the class, it ends up calling this method. That's the idea behind a constructor. Every class should have a constructor, even if the constructor doesn't do anything. Now, one thing that we will introduce here that is new is that when you create a class, you might need variables that are part of the implementation of that class. These variables we don't want to expose to the user, so we call these private variables. And so some private members I'll need to implement or make this class work is I'm going to need an int that stores the number of sides, and I'm going to need a private int to store the current value. What is on the die right now. And then how am I going to roll the die, right? When you think about taking a die and then rolling it, it's a completely random act, right? I roll it once, I get a 6. I roll it the next time, I get a 2. I roll it a third time, I get a different value. So I'm going to need to use a random number generator to implement a die. So I'm going to say private random and then generator. Again, lines 13 through 15 are things that I need to implement a die, but these are internal to the inner workings of the die. I'm not going to expose these things externally to the users of my die. You can see random shows up with an error because it cannot find the class, so I need to import that. Control-Shift-I. All right, so what do I need to do to create a die then? I can't just create a die like this because how many sides are on the die? No idea if you create a die this way. So in order to create a die, I need to at least tell the class how many sides. So I'm going to say int side. That's going to be the parameter that goes into the constructor. And then what I'm going to do is I want to say the sides that's here, I want to set it to that sides. So that can be a little weird to say because the word sides is here and the word sides is there. Some people like to do this, like underscore sides is the variable name. So then down here I could say underscore sides, assign that to the parameter sides. And what I'm saying at this point is when you make a die, and I say, new die of size 8, sides 8, then take that 8 and set it to the internal private variable sides. If the names match, things can get a little confusing. Is it referring to this sides here or this sides here? In order to figure out that I want to refer to the sides that are associated with the class, the private members of the class, there's a special keyword I can use, this. This is a way to reference the class that you're in. So if I say this dot sides, I'm now referring to the private member inside sides. So this is a handy way to reference the private members of your class without having to bother to name these things different than without having to name these things differently from the parameters that you would normally pass in to the method or constructor. Okay, let's continue out. In order to create a die, I'm going to need a random number generator. So I'm going to say generator equals new random, and that should be enough. Now, one of the cool things about a constructor, well, let me just take a step back. So you might be having a hard time visualizing what this does and how this works. So let's go back to dice run, and let's now in here, let's make a die. So I'm going to say die D12 is new die, and then my constructor, remember, needs an argument, so I'm going to say 12. This makes a 12-sided die. Or I can say die normal equals new die 6, regular die. So it's a regular 6-sided die. And this is the constructor again, and it corresponds to this method here. Now, as we learned last time when we used the random number generator, sometimes you want to be able to seed the random number generator with a specific value so that it makes it easier to test or predict the numbers that you're getting out of the generator. So I should probably have a way to do that in my constructor. But I like this constructor because it's simple and easy. So one of the things that you can do with methods is you can what's called overload the method. You can create another method with the same name. And as long as the parameters are different, this will be acceptable. So I can say int sides, int seed. And what I'm going to do now is I'm going to implement this constructor a little differently. I'm going to say this dot sides is sides. This dot generator is new random with the seed. So now I have two implementations of my constructor. This first implementation takes one parameter, just a number of sides. The second implementation takes two parameters, a number of sides and a random number seed. And this way I can then create a die with a predictable set of dice rolls because I know what the seed is. This is called, again, overloading, method overloading, and it's perfectly acceptable to have two methods with the same name, but since the argument list is different, it's okay. And you've seen this before with system out printf and system out println. They're both overloaded to handle integers or handle strings, handle different data types. Now's the time I should probably think about implementing some of these properties and methods. And let's start with get sides. Let's start with roll. Why not? So what does it mean to roll a dice? Public, what do I need to return? Let's return an int, which represents the value on the die, roll. That's the name of the method. And I don't need to pass in any arguments to roll a die. When you roll a die, you just shake it and roll it, right? So what am I going to do when I roll this die? Well, I'm going to say this dot value is assigned this dot generator dot nextInt. Give me a random number between 0 and this dot sides plus 1. Whew. Got to think about that one for a minute. But before we do, remember this roll is going to return an int. So I need to say return this dot value. All right, now let's just think about what I did here for a second. This dot generator is a private member of this class. Generator is of type random, which has a method called nextInt. We know this because we've done this before. NextInt takes an argument of sides. So if, for example, if I make a 6-sided die, this is going to say nextInt 6, which is going to return a value between 0 and 5. If I add 1 to that, I get a value between 1 and 6. This is going to generate a random value between 1 and 6, which is just like rolling a die, a 6-sided die, and then set that to the face value of the die and return the face value of the die. Let's go see if we can implement this. So system out println normal dot roll. Let's go ahead and execute it now and see what happens. We get a 1. Let's execute it again. That time I rolled a 5. I rolled a 4. Oh, I rolled a 6. So it looks like it's working. Maybe I want to roll the 12-sided die. I could just change this normal to D12 dot roll. 9, 12. So it seems to be working. Maybe I want to kind of see what's happening under the hood. I can go back here to die Java and I can put a breakpoint here. And then rather than running the code, I can now debug the code. And it will stop right here and I can see what's happening. So I'm rolling the 12-sided die because it's D12. So what's going to happen here? This sides is 12. It's a 12-sided die. So it's going to call generator nextInt with 12. And then it's going to add 1 to it. So I'm going to step over this. Now this value is 4. So it rolled a 4. And then it's going to return the 4. And then it's going to print out the 4. Ta-da! Cool. Okay, at this point our class is not completely done. We've only implemented roll in the constructor, so we still have to implement a method that will allow us to get the current value on the die so that we do not need to re-roll it in order to find out what value we already rolled. Then we also need to implement get and set sides. Let's keep going then. Public int get value. This takes no parameters. And this is going to return this value. Right? This just says, show me what's on the face of the die. The face of the die is determined by when you roll it, something shows up on the front of the die, and this just re-retrieves it. So that's a way of getting what's on the die without having to re-roll it. That brings up a kind of an interesting point. When you construct your class, you should probably initialize all of your private members. And one of the members I don't initialize is the value of the die. What is the initial value of the die? If you take a die, if you're playing your favorite board game and you take a die out, it's going to have a value on the face before you even start playing the game. So this should have a value. I could do something like this and say, this value is going to get 1 to start. That's a safe thing to do. Or what I could do is something a little more random. I could say this value gets this roll. So that says create the die, roll it, and then give it an initial value. That's a little more random. And I'm going to do that and place that here as well. So now when I create a die, it's going to have an initial value. And I can test that here. So I'm not going to roll my die. What I'm going to do is I'm going to make that 12-sided die, and I'm just going to say d12.getValue. And you'll see that by doing this, it's going to pull out an initial value. And just to show you that it's not going to re-roll every time it does it, I'm going to print it out twice. Run that. 2 6s. I run it again. It's 2 2s. It's different every time because every time it creates the die, it's got some arbitrary initial value that it starts with. And it doesn't necessarily have to be the same value every time because of the way that I implemented the constructor, right? The constructor will randomize the initial value because it generates a random number and then rolls. Let's conclude by implementing our get and set sides. Generally, you do not want to, you might say, well, Mike, why can't I just do this? Public int sides, right? You could, and there's nothing wrong with doing that. And then if I do public int sides, I can come over here, and now that it's public, I can say d12.sides. Oh, see, there it is. It's just a public member of that class. Nothing prevents you from doing that. However, the convention and the way most people program is to not do that because you want to use a concept called encapsulation when you build your classes. That is, you want to hide how you implemented the class from the user of that class. There's benefits to doing that. One of the benefits is that when you go to build another class that derives from this class, it can inherit all those features, and it can't inherit variables. It can only inherit the methods. So let's make what we call get and set methods, or also called property accessors, for the sides value. So let's make our public int get sides, and this should return this dot sides. And then we should have a public int, public void, doesn't need to return a value, set sides. And this takes a parameter of int sides. And this should set this dot sides to sides. So now we have what we call this a getter and a setter for this property sides. This is a better way to implement reading and writing state from your class than using a public variable because, again, this is easier to reuse and easier to hide the details of how it works from the user of your class, which is a kind of important concept, as we'll see. So what's neat now is I can make a 6-sided die and then say normal get value, and then maybe I can print out a normal dot roll. Then I can do a normal dot set sides. Let's make it a 20-sided die now. And then let's re-roll it, but now it's going to have more sides on it. It's kind of weird when you think about it, because when you think about a die, you just, if it's a 6-sided die, it's a 6-sided die. It's a 12-sided die, it's a 12-sided die. Some of you may argue that I shouldn't allow the user to change the sides on the die. That kind of defeats the purpose of what a real die would be. And I certainly could do that simply by going in here and removing the set sides method. Right? If I move the set sides method, then I have an implementation where you can only retrieve the current sides, and the only way you can the only way you can initially set the sides is by constructing a die. If I make this public, I can't prevent people from changing the number of sides. That's one of the reasons why encapsulation is so important. It allows you to control these private members. You can control which ones are read-only and which ones are read-write and which ones are write-only if you want. So what this is going to do again is it's going to get the value of the 6-sided die to start, roll it, and then it's going to change it to a 20-sided die and roll it. So, and you see it works. So I have a 5, and then it rolls a 2, then it changes it to a 20-sided die and rolls an 18. One may argue that this is not a good feature to have in a class of type die. If I'm trying to implement what it means to be, this thing that you roll, generally speaking, in the real world, we can't change the shape of that thing from one size to another. And so it probably isn't a good idea to have this method, but I'm going to leave it in. Building and designing classes is much more difficult than using the class to make objects. And that's kind of a recurring theme here. It's a little bit of art and a little bit of science to go through and implement a class. But all classes need state, and we store those states in private variables as a rule of thumb. All classes should have constructors, and the rule of thumb that we want to follow here with constructors is that you should always initialize all of your private members in the constructor. You can overload the constructor to do different things, but it's important that you initialize all the values. Any of the properties that you want to expose to the user, you should do that through getters and setters. Like here I have get value and get sides and set sides. By doing this versus making these values public, you're allowing the designer of the class, that usually is you, to control the users of the class ability to change certain elements of that class. This is called encapsulation. Maybe I decided I don't want users to be able to change the sides on the die. I want to hide that implementation from the user, so I can simply comment it out, like so. And when I go back to my code, you'll see I have an error here because this is no longer a method of that class. And this ends up being pretty valuable because now I've changed the way my class gets implemented, and I can control the state of the number of sides of the die. Okay, as part of this final example, through a little bit of copy and paste magic, I have put some code in here to create some various sized die and then roll them. So let me just explain the code here. I'm making a 6-sided die here, a 12-sided die here, a 20-sided die here, which I'm uniquely calling the Skull Crusher. And then these 3 print statements will show me what sided die I've rolled and then show me the results of the roll. So for example, it says rolling %d, d12 get sides, sided die, and then d12 roll. So when I run this, I should see 3 prints, 3 lines printed. Rolling 6-sided die, 3. Rolling 12-sided die, 12. Rolling 20-sided die, 8. Okay, I hope you found that code sample useful, but what I'd like to do at this point is sum up the important elements of the example you just saw. When you create a class, these are more or less conventions that you should follow. You don't have to follow these conventions, but people that write good code do. So let's start with the first one. Every class should have a constructor. Any variables that you need to use to implement what your class is set out to do, those variables should be set as private, not public. You should initialize all your private variables, that is, give them meaningful initial values within your constructor. If you need to accept parameters in your constructor, and then use the parameters given to the constructor to set initial values on your private members, use the this keyword to disambiguate the method parameters from the private members. And then last but not least, use get and set methods to control access to the private members. You might have some characteristic that you do not want the user to change, so don't implement a set method in that case. Only implement a get method. Well, this concludes our lesson on classes. There's definitely more class type stuff to come in lesson 7 and lesson 8. We will take an even deeper dive into building our own classes. As you can imagine, This is at the heart of object-oriented programming, so it will be very much a theme of what we do from here on out. Once again, I thank you very much for taking your time to watch this, and if you have any questions, comments, or feedback, please feel free to post them on YouTube. Thank you, and have a great day. Bye now.